Good morning, my dear students. Welcome in strength of material. So now you know very well we are in a what moment of inertia. So now, my dear students, our today's topic is use of use of parallel axis theorem and use of perpendicular axis theorem. So now today's lecture we're going to see where we have to use our parallel axis theorem to solve our problem of moment of inertia, and where we have to use perpendicular axis theorem to solve our problem of moment of inertia. So see, my dear students, so before knowing this use of parallel axis theorem, just we should know what is parallel axis theorem. So see, my dear students, parallel axis theorem means what? How we can write it? So see, parallel axis theorem means moment of inertia about any reference axis of a particular object. We'll see later on with example how it is. So see, I means moment of inertia, AB means any axis. So moment of inertia about xx or moment of inertia about yy. So you know very well we have a body, and that body having what? Xx or yy axis. So see, my students, so this is what moment of inertia about x axis plus area, product of area into height square, plus product of area into height square. So what is Ixx? Yes, Ixx means mi. What is a means area. What is Ixx? Ixx means mi. And what is Iyy? Iyy means also mi. So Ixx or Iyy. So body having two axes, xx or yy. So calculate mi about xx and calculate mi about yy. So Ixx and Iyy means mi. And what about a? A for area. And what about h? H means distance. Distance between axis. Distance between axis. Okay. So see, my distance with example. Supposed to be assume this is a I channel. This is a I channel. Supposed to be this I channel, and you know very well I channel. Okay. So another example we have what? T. Okay. T channel. This is the second example. So see, this body number one having what? Axis, you know very well. This also having what? Axis. So we have axis of this body. So you know vertical axis means y, and horizontal axis means x and y. So see, when we have to use this parallel axis theorem, see, when our axis is unsymmetric, that time you have to use what? Parallel axis theorem. When our axis is what? Unsymmetric axis. So out of these two, in our first figure, out of these two, xx and yy axis, which is a unsymmetric axis? So see, xx is a unsymmetric axis. So this is what? Unsymmetric axis. Why? Because see, just top side of this xx and bottom side of xx, you'll find some difference in the dimension. We'll find some difference in the area. See, this top area about this above area from this xx and below area from this xx having some difference in sizes and dimension. So see, just top side of this axis, you see xx, horizontal axis xx, just above this horizontal xx axis we have what? Smallest area, smallest dimension of this I section, and just below of this x axis having what? Biggest dimension, biggest area of this I section. Okay, so difference in area about xx axis, about axis, it means unsymmetric axis, imbalance axis. So imbalance axis, unsymmetric axis, when we have it in our what? Area, any part, so that time you have to use parallel axis theorem. So see, in second figure we have what, see this is what x-axis. So above x-axis having what, some different dimensions, and below of this x-axis having different dimensions. So use, so that means this axis becomes unsymmetric. Unsymmetric imbalance axis. So unsymmetric axis or imbalance axis is nothing but parallaxis theorem. You have to use this parallaxis theorem to solve this kinds of a problem where we have what, unsymmetric axis. And when we have a symmetric axis, that time you have to use perpendicular axis theorem. So same example we have to take over here. See, y axis and x axis. See my dear students, this is what y and x. So see my dear students, symmetric axis. So see this y and y. So in this I section we have y axis, which is symmetric. What do you mean by symmetric axis? What do you mean by balance axis? So see, symmetric axis means, see, y axis vertical axis. So just left side of this vertical axis and right side of this vertical axis. See, left side of this vertical axis having what, this kind of a shape and dimension. So in similar way we have a right side of this y-axis having a same and similar dimension. So left half and right half having a same dimension. Okay, so that's why this axis is called as what, symmetric axis. So see, similar over here in a T section, second example have with us. So see, y-axis, left side of this y-axis and right side of this y-axis having the same shape, same area, same dimension. Okay, so that's why it is what, symmetric axis. So whenever we have a symmetric axis in our part, that time you have to use perpendicular axis theorem. So what is mean by perpendicular axis theorem? So see, perpendicular axis theorem means ixx plus iyy is called as perpendicular axis theorem. So this is, my dear students, perpendicular axis theorem. So these are the two axis theorems have with us, parallaxis theorem and perpendicular axis theorem. When we have unsymmetric axes in our part, so that time you have to use parallaxis theorem. When we have what, symmetric axis in our part, that time you have to use what, perpendicular axis theorem. Okay. So now, my dear students, next concept in our today's lecture, that is what, polar moment of inertia. So see, my dear students,